Question 6, type the correct answer in the box. Use numerals instead of words. Consider the geometric series. 4 plus 12 plus 36 plus 108. The sum of the first blank terms in the series is 4,372. So we're obviously trying to find the sum, and we know it's a geometric series because of the title of this unit, and the question says geometric series. So that means we're going to use the geometric series summation formula first. So let's write down that formula. S sub n equals a sub 1 multiplied by the ratio raised to the n power minus 1, all divided by the ratio minus 1. So let's set this problem up. So let's start with S sub n. Let's think about, okay, what does this number 4,372 represent? Well, it represents the sum of the series. Well, and that's what S sub n represents. So they give us S sub n in this problem, 4,372. We obviously know the first term in this problem, a sub 1, that's just 4, multiplied by the ratio. So this is our common multiplier. So if we look at the terms and try to decide what our common multiplier is, a lot of you can probably just see it. But if you're not one of those people, you can kind of do this backwards. Take the second term and divide it by the first to get the common ratio. So the second term is 12 divided by the first term is 4. 12 divided by 4 is 3. Let's check it. Is 4 times 3 12? Yeah. Is 12 times 3 36? Yes. Is 36 times 3 108? May need a calculator to check it, but it is. So that is our common ratio in this problem. So R is 3. N is the term we're looking for, or in this case, the total number of terms we're looking for. And that's the question. The question wants us to figure out, okay, how many terms do we have to take to add together to get 4,372. So we're going to leave n alone in this problem. So n stays in. And then, of course, minus 1, all divided by the common ratio, which again we already said is 3, minus 1. So we need to solve for n. It's not multiple choice. So we could work backwards, but it would take a little bit of work to figure this one out, working it backwards. We'd have to guess a lot of different numbers. So let's simplify this just a little bit. Let's start by go and simplify 3 minus 1. That's obviously just going to be 2. Anytime you're solving an equation that involves a fraction, I always encourage you, let's get rid of the fraction first. So think about this fraction we're dividing by 2. So we want to do the opposite in this problem, and we just want to multiply both sides by 2 to undo that division. So I'm going to multiply this side by 2, and that cancels out with this divide by 2 here, but we got to do the same thing to the other side, and we'll definitely need a calculator for this. So we're taking 4,372 and multiplying it by 2, and we get 8,744. So we bring everything down, and we're left with 8,744 equals 4 times 3 raised to the n minus 1 power. Our next step is going to be now division, because we want to undo that multiplication by 4. So that will cancel that 4 out. We need to take 8,744 and divide it by 4. Again, let's use the calculator. So 8,744 divided by 4, that gives us 2,186. So we bring everything down. We have 2,186 equals 3 raised to the n minus 1. So we're going to add 1 to both sides. About out of space, so I'm going to move this over here. 2,186 plus 1 is just 2,187. Over here, the 1's cancel out, and we're left with 3 raised to the n power. At this point, we could use logarithms to get our answer. However, 2,187 with respect to 3 is a pretty small number. So at this point, I feel like guessing and checking would be easiest. So let's just take 3 and raise it to a random number 4. 3 raised to the 4th power is 81, not 2,187. So let's skip ahead. Let's go to 6. 3 raised to the 6th power, 729. We're getting closer. 3 raised to the 7th is 2,187. So n equals 7, which means the sum of the first 7 terms in the series is 4,372. There are probably quicker ways to do this without the formula. You could have just listed the first 7 terms and then added them together to get 4,372. Probably quicker in this instance, but sometimes the formula is quicker, so I wanted to show you that process.